While RNA editing is critical for generating the hundreds of thousands of proteins that keep us alive, splicing errors can lead to devastating health problems. One example is an often fatal disease called spinal muscular atrophy, or SMA. It's the #1 genetic cause of infant death. SMA is caused by too little of a vital protein called survival of motor neuron, or SMN, in the spinal cord's motor neurons. Too little of this protein causes the motor neurons to die and the muscles they control to waste away. The SMN1 gene, which produces the SMN protein, is missing or damaged beyond repair in SMA patients. Humans have a second SMN-producing gene called SMN2, but this gene is a poor backup because it produces very little functional SMN protein. This deficiency stems from a mistake during RNA editing. Remember, that's the process of forming a coherent RNA message by removing the gibberish letters or introns. But what is this mistake, and how does it cause SMA? Let's say the SMN gene generates RNA copies made up of introns and exons like this. Normal RNA splicing would delete the introns, the gibberish letters in blue, and leave only the exons, the red letters, generating the following message: draw a big house on the corner of the wide street. In SMA, it turns out that during RNA splicing, the 7th exon of SMN2 is skipped by the machinery that edits RNA. Skipping of exon 7 generates a faulty message: draw a big house on the wide street. Just like removing word number 7 in the sentence leads to a statement that makes no sense, removing exon 7 in the RNA results in a defective protein. Remember that SMA patients have to rely solely on the SMN2 gene to produce the survival of motor neuron protein. But due to exon skipping, not enough usable protein is made to support normal muscle development. Infants born with the most severe form of SMA often don't make it to their 2nd birthday. But researchers have been studying how to fix this splicing problem. One solution is called nusinersen. It enables SMA patients to make more SMN protein. But how? Nusinersen is a short sequence of RNA that binds just after exon 7 in the unedited RNA message. This tiny piece of RNA prevents exon 7 from being skipped. It is called an antisense oligonucleotide, or ASO. Exon 7 is now included in the edited RNA message, which in turn generates full-length functional SMN protein. By preventing exon 7 from being skipped, nusinersen reverses symptoms in SMA patients.